All right. So there's that. All right. So before I actually continue with the PowerPoint here, so let's list all the things. How are we decreasing species diversity, also called biodiversity, loss of biodiversity? Well, here, let me show you this here. So this is kind of cool. This is an interactive thing. Did I show you this already?
No.
No, it's kind of cool. You can go to ancient Earth, you can go to Paleo Earth, you can go to Ice Age Earth, you can go to warming Earth.
Yeah, what about the future?
And that's all I got. You know, the cool thing is about this, you go to Paleo Earth, and look, the CO2 is 392 parts per million, and then you move this, and you go back, and the parts per million of CO2 and O2 changes. Remember when he said the Carboniferous in the video the other day? He was talking about bugs. You know, what did he say? Millipedes the size of alligators or something?
Yeah.
Imagine that. That would freak me right out. Anyways, yeah. So anyway, it's pretty cool. This thing's pretty cool. Anyways, if you go to, so some of these charts are misleading because the units aren't the same, but I'll show it to you anyway. So if you go to biodiversity, and it's saying here on the bottom millions of years ago. So here's 500 million years ago, up to 50 million years ago, and then it goes to like 0. But over time, so pre-humans, biodiversity, the gist of this, it fluctuates a little bit. There's mass extinctions, and there's an article I'm going to give you. I guess I'll give it to you. I might give it to you tomorrow, but if not, then Wednesday. It's called the 6th mass extinction, which we are in, which is due to the anthropogenic activities.
Extinctions at 250 million years ago?
Right, you're right. So when you see those drop-offs, so, you know, let's see, 1, 2, 3, 4, I mean, you can count 5 of them, right? I don't know. I don't have everything memorized, but if you look at all the dips, 1, 2, 3, 4, I don't know, 5, so they dip. Those are mass extinctions because of but this is just marine animals. So I was trying to find a chart that matches the one I'm going to show you in a second, but I couldn't. The point is, and I think you understand the gist of it, is that, you know, from ancient Earth when there was no life because of the, what they call the primordial soup. Have you heard that before? So all the stuff that was just forming on Earth after the accretion of the planet, do you know what that means? So balls of gas in space are spinning slowly, and they start to heat up, and then they spin faster, and particles start slamming into each other, and then they get big enough where they eventually have gravitational pull, and they keep spinning faster and faster, pulling in more and more, and then they form a planet. And when that happens, some planets, and ours happen to be the only one we know of, was able to form life from all that. Anyways, that life eventually started to flourish. So over millions and millions of years, there was, lots of life. And then, if you fast forward, warming Earth. So this here, actually, here, let's do this, just to put it in perspective here. There's the temperature from 1951 to 1980. The global mean temperature, as far as changes, I believe is what they're going with here, how the temperature has changed, so it's increasing there. But you can actually move this here, and you can see how the color changes. I don't know if you guys can see. This is temperature difference. Down, the blue is -2, top is 2, which is red or orange, and you can see if we go back 100 years ago. So there's the changes. So if we go to our country here.
What are the purple things?
Those are like cities. Calgary, Los Angeles, New York. So that's 100 years ago. And then that's now. So or 2012. This was made in 2012, this thing. So it's pretty cool. Anyways, why am I showing? I'm getting off task here. Biodiversity. So if you look at this chart, years before 2012, 40 years ago. This is percentage of percent change in abundance of 2,700 animal species since 1970. So you're at 100% here, and then it goes up a little bit, and then down here to 0. I know it's cut off there, but it doesn't quite reach 0. It stops at, let's say, 5 years before 2012, which is just about here. So we're down somewhere around 70%. So anyways, the point I'm trying to make is the increasing biodiversity, pre-humans, and then once we have established here, then biodiversity.
How would it get above 100%?
So it says change. So you can have a change that's above 100%, but you can't have more than what's not. You can't have more. So don't think of that as like, here's all the species, and then all of a sudden you have more than that. The change means there was an increase in species.
Okay.
Does that make sense?
There's
Not
like
negative
a
change.
new species.
Like speciation is what it's called. Yeah, yeah.
Okay.
So new species, or that's a little different. But yes, yes. Good question. So anyways, this thing's pretty cool. We'll come back to this. I use it for different things. So if you look just real quick here at the North Pole. So dark blue means -2 change in the temperature difference. The poles are really affected significantly by the global warming and climate change more than anywhere. The coasts as well, but let's relate it to habitat loss in this unit, biodiversity. What's happening up there in the North Pole? What species are at risk?
Polar bear.
Yeah, big time. Polar bears is the one everybody talks about. There's other species, but why? What's the problem with polar bears?
They don't know how to use to love them.
Right, so why is that a problem?
Because they don't know where to live.
Yeah, they don't have any land, so they're swimming a lot more than they. I saw it was like a Planet Earth or something to that effect, and this one research scientist was studying polar bears, and they said one of them was swimming for miles trying to find food. And, it's just bad news. Anyways, that's not what we're really talking about. Not really, sort of habitat loss. All right, so how are humans affecting the loss of the species diversity and biodiversity? So let's just write some things down. It's the same things we've been talking about over and over again. So let's just write some main terms here. What's a big one happening in Brazil?
The rainforest.
Yeah, deforestation. Make sure you write like literally the word deforestation. It's clear cutting, kind of the same thing, but deforestation. Good. What else? What else are we doing? What's the biggest thing we do? We wipe out habitat by doing what? Yeah, we're building man-made structures, we're places to live, businesses, agriculture. Those are the biggest ones that wipe out habitat and species diversity. And we use quite a bit of water. Right, clean water is going to be a limiting. It is a limiting resource, but so that's the 3 I wrote down. Those kind of cover not most, but a big chunk of habitat loss and species diversity decreasing. Is we're clearing so we can live there, or we're clearing so we can build homes, businesses, whatever it is, and then we're using up all the water and diverting it and using it for irrigation, like moving it around and for our needs. So that's decreasing species diversity. The species that can adapt to these new environments, what do?
Survive.
The ones who can't adapt.
Oh. Die.
Die, extinct, right? And then the ones that can adapt, well then they can adapt. They will survive. We'll talk more about that. What about nature? How does nature? So we've had 5 mass extinctions. We didn't have anything to do with those. Volcanic activity. So natural activities, good, could be and actually that's part of the unit, specifically natural disruptions. We'll talk about that. What else? Something that might be more widespread. Yeah, I'm thinking more of like natural disasters.
Hurricanes?
Yeah, flooding. to storms, right? Hurricanes,
I see what you're
droughts, fires. So we'll get more into that specifically. It's like a specific part of the unit. But yeah, so it's not just us. Nature does it as well. However, I feel like if it's a natural process, that's kind of normal. All right. And again, the result of these changes that we make are natural changes. If there's more diversity, the ecosystem will survive. If it's all one type, it will not. That's the biggest part I'm trying to stress here. All right. Okay, moving on here. The bottleneck effect. All right, so there's a lot of things actually in this chapter that I looked at that, if you go all the way back to the beginning, you don't have to write any of this down. Just talking about evolution and how things progress. Artificial selection, natural selection. Let's just real quick review. This is not stuff we're going to write down. What's natural selection mean?
Those best fit to survive in a climate will survive.
Right, the fitness of the organism. So the most fit will survive, is able to adapt to changes. So that's natural selection. What's artificial selection? Why are they showing dogs?
The humans bred them.
Right, so we're artificially selecting which species will make it and which will not. Right, so there's artificial and then there's natural. And then there's some other things, mutations, gene flow, genetic drift. We're going to get into just bottleneck effect. And again, there's so much to cover. I'm just sticking to what's in the curriculum. Bottleneck effect is in there. So you need to know what this means. A reduction in the genetic diversity of a population caused by a reduction in its size. So, if you have a certain population of some species and there is a drastic reduction, so losing lots of members of that species, the genetic variation will kind of go down with it. Low genetic variation in a population can cause increased risk of disease and low fertility. Again, we're learning maybe a new term, bottleneck effect, but it's all related to the same theme. More diversity is better, right? So, I'll let you get all this down, then we'll talk about what could cause that, what would cause the reduction in the population. Again, if there's a bottleneck effect, that means less are able to adapt to future environmental changes, because if you decrease the genetic variation and more of those, the low numbers of the population, but of those species that still exist, there's going to be less ability to adapt because they're all very similar genetically. So eventually that could lead to extinction, and extinction, if you need to write it down, death of the last member of a species. And I believe this article talks about threatened and extinct. So there's different levels. Let's see. I want to say it talks about it in here. Anyways, you'll read it. I just read it, but all right. So let's talk about what would decrease population. So I want you to write, after you're done with this page here, let's write this down. So what causes the bottleneck here? Right? So why is there a rapid decrease in population? What could cause it? What do you guys think? Throw anything out there. Hunting. Very good. Yes, absolutely. What did the book call it? Human harvesting. That sounds disturbing, especially if you misinterpret it. not harvesting humans. Human harvesting, meaning hunting. Or we're taking it out of its habitat or ecosystem for whatever reason, to stuff it and put it on the wall, because that's really cool. Or, for food. Whatever, okay? What else? Disease. What is it?
What?
What'd you say?
Fishing.
Fishing. Yeah, okay, here. No.
What do you mean?
Okay. To be fair, no one
Fishing
says
are
I'm
not
gonna go
the same
hunt
thing.
fish.
Exactly.
They say I'm gonna go fish, right? So if someone says I'm gonna go hunting, they mean I'm gonna go shoot a deer or a turkey or something, right? Yeah, pretty sure that's illegal actually to shoot fish.
Bow fishing?
No,
You can
not
bow
bow fish, but you literally mean shoot fish.
Yeah, like literally. Yeah, you can't do that. Hunting, fishing, good. Someone said disease. Good. What else? I'll give you one here. Natural disaster. So that hurricane would have just basically destroyed.
The
Wow.
Bahamas.
Yeah, whatever is living there is shot. The habitat, it's done, right? So that's a good example. So that could happen to some of the species on that island, right? Drought. Right, yeah. So we can just, if you want to write some specifics, that hurricane was one. A drought could be one. So we don't need to list all the specifics, but yes, flooding, kind of the other things we just listed earlier. What else? I only have one more thing written down here. So all of these, actually this one, these would be direct like hits to the species. The other one I'm just going to give you here is more general, just habitat loss. That could come from a variety of different reasons. This natural disaster could cause that. Humans can cause that, right? So habitat loss, most likely it's human, but it could be natural. Again, habitat loss is just the general term, but yeah, those other things, disease, natural disaster, hunting, fishing, some of those go under that category. But all right, let's see. Does anyone know where this has happened? Kind of I'll just give you a hint. Really fast animal. Cheetahs. So write that down. Cheetahs. Evolution by bottleneck effect. If a population experiences a decrease in size, they go through a bottleneck, meaning some genotypes will be lost, and the genetic composition of survivors will differ from the composition of the original group. So I would like you to actually write that part down. The genetic composition of survivors are different than the original group. I can write that if you want me to. So genetic composition of the survivors are different than the original group. And again, a lot of these pictures are in your book, but I can just read it to you. So it shows you here, up here you got 10% no spots, 50% small, 40% big. The bottleneck happened, 0% no spots, 33 small, 67 big. And then down here, the survivors, as a small pot, they reproduce, and then your offspring from the survivors will be essentially identical to those survivors because there isn't the variation. So it's really important, and I'm hoping you kind of already have kind of learned some of this in biology and it makes sense to you already. We don't need to hammer on it, but if you have a lot of diversity and they have offspring, there'll be a lot of diversity in the offspring. If you limit your diversity, then the percentages here are exactly the same here. 0, no spots, 0, no spots. So originally there were cheetahs with no spots. I didn't know that.
Can we get a picture of a no spotted cheetah?
I don't think. See, the thing is, they don't exist anymore. That's the point. So this has already happened. And there's a woman, I this point, who graduated from Byrne, and she works with cheetahs. Or she did work with cheetahs. Now she works with mountain lions, I think.
Yeah.
Her name is Anna Kussler.
Yeah, she came in.
Did she come and talk to us?
Yeah.
In AP Chem?
Yeah.
What did she talk about? Cheetahs?
Yeah.
Mountain lions? Both?
It was cheetahs, and now she's doing mountain lions.
Yeah, and but she said things are getting a little better, if I remember correctly.
Yeah.
Yeah. So, anyways, does it make sense to everybody here that if you eliminate a massive amount of the numbers of a population, that the genetic variation goes away, and therefore the offspring won't be varied, or genetically different? Does that make sense?
It doesn't seem like it's necessarily a bad thing, because they're adapting to more better survival.
Let's talk about why it is a bad thing.
Because there's less diversity.
But why is that a bad thing?
There's no spotted
Right. Any sort of environmental change or disease that this type of genotype or genetics can't handle, then they'll all die. In fact, we're going to write that.
How would spots protect you from a disease?
That's just how it's expressed, right? So there's phenotype and genotype, right? What's the difference?
Phenotype is physical.
Right. So phenotype, I always remember this when I was a kid, is like you can see, that's the genes being expressed physically and you can see it, right? So that's just a phenotype of the genetics of that cat, whatever that is, right?
Yeah, but-
So the genes of this one is different than this one, which is different than this one. So that type of gene, that's gone. So if there's an environmental stress or a disease or something that happens to these, they may all die, where that one might have survived.
But that one is dead for a reason because it didn't survive in the first place.
No. So, I mean, you're right, but it could have been wiped out by hunters. That's not, the species can't prepare for that,
Yeah.
right? So it was unjustly wiped out. It isn't that it didn't adapt, it can't fight back. You know what I mean?
If that is how it was killed.
Right. So what you guys are getting at is it was a natural process that caused this. Like a natural
I'm
genetic.
Thinking, they didn't have any lack of spots meant they couldn't camouflage and hide from predators.
Okay, fair enough. So you're saying it's like they by natural.
Okay.
So okay. I mean these are good questions. I'm glad you're thinking deeper about it, and it's good. It's good. But not to keep going on and on. Do you understand that if there's limited genetic, a disease could wipe them all out, for example? So let's just make sure we write that down if you need to. Again, I'm not going to write every little thing down. What I have here is if a species has less variation, it is less able to handle environmental changes and will have an increased risk of disease and low fertility. So actually, low fertility, that's something we should write down. Make sure you write that down. That is that's a natural consequence of decreased genetic variation. That happens in all species. If you have a limited variation in a population, they try and reproduce, basically nature's like, nope, that's not going to happen because that's not healthy and bad things are going to happen. That could lead to extinction. So, not to get weird, but when people try and do that, there's all types of problems with babies, or they can't even have babies. So if there's people that try and reproduce with people very genetically similar, aka same family, right?
Yes.
So it doesn't work, and it doesn't work, and this is exactly what we're talking about. So if you limit the variation, that's not, it's gonna have low fertility. So low fertility, which could lead to extinction, and increased risk to disease, is a big one. All right, good. All right, a few more minutes here. All right, here's what I want you to do. I'm gonna give you 3 terms. See if you can come up with definitions on your own out of your head. Here we go. Specialist species, generalist species, invasive species. So those are the 3 I want to talk about here. We'll pick up with it tomorrow. Give me a few more minutes. So specialist species, invasive species, and generalist species. I think I said the order different, but specialist species, generalist species, invasive species. So go ahead and feel free to talk to somebody. Come up with kind of your own definition. If you had to define those 3 words, terms, what would they be?